Greetings and thanks for the opportunity to speak with you today. My name is Emmett Duffy of the Smithsonian Institution. Together with Lauren Weatherden of the World Conservation Monitoring Center, I co-lead the project Coordinating Global Research Assessment of Seagrass Systems, or Seagrass for short, and we are grateful to SCORE for supporting this effort. We're committed to advancing global coordination of seagrass research for several reasons. Most importantly, these plants are the foundation of productive and diverse ecosystems all around the world, along the coasts of all the continents except Antarctica, where they support abundant biodiversity, including of threatened megafauna, productivity of shellfish and fish that also support local economies, particularly in the developing world. And finally, seagrasses are increasingly recognized as important habitats for mitigating anthropogenic climate change because they sequester large quantities of carbon in their biomass and in underlying soils. For all of these reasons, seagrass cover and composition are recognized as an essential ocean variable in biology by the Global Ocean Observing System. The need for globally coordinated information on seagrass systems has been recognized for some time. The first World Atlas of seagrasses appeared in 2003 and has been updated by WCMC periodically since then. Several years ago, the Global Ocean Observing System recognized seagrasses as an essential ocean variable, and we began developing the specification sheet at that time, which we expect to finalize during the course of this project. Just recently, an expert working group assembled by Grid Arendal produced a really nice summary for policymakers of the current status and importance of seagrass around the world. So all of these provide a good tailwind for us in moving the project along. Nevertheless, most research and observing on seagrasses around the world is relatively uncoordinated and uses a wide range of methods, and there is no central data repository. So there is a major need here. Want to change that. So to advance the goal of coordinating seagrass data toward a global dynamic indicator, we've assembled what we consider a dream team of partners from numerous institutions in at least 13 countries across 5 continents, including world leaders in seagrass ecology and monitoring, remote sensing, and conservation. So we had planned our first meeting in Colombia in May of this year. This was, of course, foiled by COVID, so it took us a few months to reboot and reimagine the group as a virtual workshop. But our first working group meeting commenced just about a month ago and has just concluded after 6 virtual meetings. Our group's vision is to join forces, organizing these numerous globally distributed partners to develop a rigorous dynamic picture of global seagrass status and trends, and to nurture a global community of practice that can steward that for the public good. Our mission to achieve that vision has 4 main parts. First, and most fundamentally, the key to interoperability and coordination is compatible data. So we're developing a standard seagrass data schema and vocabulary that is aligned with accepted standards and will support reporting on the essential ocean variable. Second, we're initiating a synthesis of existing data on seagrass occurrence, extent, and condition toward the first quantitative global synthesis of seagrass data in over a decade. Most importantly, this synthesis will, for the first time, combine data from both in situ field sampling and remote sensing with the goal of integrating these to create an approach and a data set that is greater than the sum of its parts. So ensuring that the developing seagrass coordination is in fact dynamic and survives and thrives into the future requires 2 additional components. First, we need accepted best practices agreed on by most practitioners to ensure that the data are rigorous and intercomparable. And second, we need a vigorous community of practice that can turn all of these parts into a whole and sustain the people and organizations that are doing the work and who need to use the data. So to achieve these goals, we have developed a draft roadmap for our 3-year project. It begins with the first workshop that we've just concluded, where we developed a draft data schema and a plan to collate the best practices and move toward collation and synthesis of data, and to establish and nurture a community of practice building on several existing communities. So we're working toward several products that are shown in the far right here. First, establishing the global data sets for remote sensing and field sampling of seagrass for use in post-2020 indicators. Second, we plan to develop a definitive guide to best practices in seagrass observation, published as an open access multimedia resource. And third, we want to weave these and other elements into a seagrass sourcebook and digital platform for the global community of practitioners and stakeholders. I should say that we are under no illusions that this will be easy. We envision that the process will take many years and lots of people beyond the SCORE grant period, and will also require us to seek funding and in-kind support to develop and sustain that community. We are optimistic that our team is committed to doing that. Again, fortunately, we have a good tailwind behind us as a start to this project as a result of a number of efforts in this direction in recent years. These include the development of the Seagrass Watch and Seagrass Net networks, and more recently, Smithsonian's Marine Geo Network. All of these have developed and field-tested best practices and have organized researchers in various parts of the world. So we are now very excited to be working together toward our common goals. So I'd like now to briefly summarize the work ongoing and anticipated by each group. The data schema group includes my co-lead, Lauren Weatherden, from the WCMC, who leads global seagrass mapping products. It also includes Ward Appletons, who leads the Ocean Biogeographic Information System, and Chris Rolfsema of the Allen Coral Atlas, among several other experts. So we have really diverse strengths in biological data and data products of several kinds that will help advance this goal. Briefly, the objectives of the data schema group are to create a standard data schema using accepted vocabularies, as well as developing scripts to translate some of the data formats used by existing programs into a common language. This group will also define the roles and responsibilities of partners for QA/QC and work to integrate the data for remote and field sampling. A final goal is to develop quantitative estimates of the costs and benefits of what we're doing, that is, of coordinating seagrass research, that can be used to illustrate the value of this data to stakeholders and policymakers as we go forward. The data synthesis group also includes a diverse range of experts and aims to assemble a database of existing records of seagrass occurrence. And the data will be synthesized in a meta-analysis that presents a current consensus on the status and trends of seagrass globally and that refines existing maps. We expect this synthesis will also build the foundation for an accurate assessment of seagrass ecosystem services, which is urgently needed and has begun in the Grid Arundel report out of the blue that I mentioned earlier. Importantly, we have some good momentum in this direction, as one of our members has generously agreed to dedicate a postdoc to the project, and we've also just recruited an intern to assist with the big initial job of data coalition and QA/QC. Finally, we are also building on the strong efforts done by Goose and the Pegasus project of Future Earth that have started this work. So again, ensuring that seagrass data collection continues to be intercomparable and useful at local and global scales requires spreading best practices. So the best practices group includes leads of the Seagrass Watch and Seagrass Net networks, as well as members of major remote sensing efforts, including the Allen Coral Atlas. Major objectives of the best practices group are to hammer out agreement on comparable protocols, establish connections between remote sensing and field sampling approaches, and to produce a multimedia handbook to facilitate that process. Finally, uniting all of these efforts is the need for a formal, well-connected community of practice that can spread the best practices and ensure that stakeholders and scientists and other interested parties are able to find one another and work together. We have several members that have helped build such networks in various parts of the world. A concrete product of this group that we envision is a digital platform and what we call a source book that brings together the efforts of the other groups in an accessible, user-friendly format. This includes a registry of seagrass workers and systems, links to the best practices and training materials, and illustrations of case studies aimed at stakeholders who need guidance in assessing the status and trends of their seagrass resources. So we have a lot of work to do, and we recognize that it will be a challenge. But we're confident that the time is ripe. There's substantial enthusiasm around the world to accomplish this. We have an excellent, diverse team of people on board, and they are willing to work. So we look forward to the next phase, and we very much hope we will all be able to meet in person to advance these goals. Thank you very much again to the Scientific Committee for Oceanic Research for your support.